couple of more applications. So it will basically pass the low frequencies, okay, low frequencies, and then blocks high frequencies, okay. What would this number be? That depends upon the over here, okay, the values of the capacitor and the resistance, and basically this is known as the cutoff frequency. Fc equals to 1 over 2 pi RC. Okay, you plug in the value of this resistor, this capacitor. So say you get 1 kilohertz. Okay, what does that mean? It will allow frequency to go past which are 1 kilohertz and less. Okay, anything above 1 kilohertz will be blocked, greater than 1 kilohertz. Okay, so what is happening over here in this circuit over here that you see on the top right is actually acting as a low pass filter. Okay, I also want you to take you back to week 2 lecture when we learned about the capacitive reactants. Anybody remember what was the capacitive reactants? What was the equation for it? X equals to 1 over omega c, and then it can also be written as 1 over 2 pi fc. Okay, so say you are providing an audio frequency at the input of some 50 hertz, frequency over here. Okay, the gain for this circuit will not change regardless of the change in the frequency of this audio signal. In order to make a low pass filter, what we do, we add a capacitor over here. Okay, this is basically an inverting amplifier, right? If I remove the capacitor, it's an inverting amplifier. I'm now just adding a capacitor in parallel to R2. The values of this resistor and capacitor are going to define the slope for the gain here, which will be dependent upon this equation that I just wrote over here. And we'll do a graph too. Okay, so capacitor will now react to the change in frequency. As the frequency goes down, what would happen in this equation? If the frequency goes down, what would happen to the reactance? What would happen to the reactance? Increase, because there's an inverse relationship. The reactance is going to be increased, which would mean what? Which would mean over here, this two as a block are going to offer more resistance to the output signal, correct? And when that is going to happen, your output voltage is going to be bigger. And we know the gain is output voltage over input voltage. If this number is bigger, then what is going to happen to your gain? Your gain is going to be, your gain is going to be increased. So capacitor reacting to the change in the frequency. As the frequency going down, the reactance is going to go up. So this resistor capacitor combination will offer more opposition to this signal over here, causing the gain to go up, causing this gain to go up. When the frequency, and similarly, when the frequency increases here, if the frequency increases, the reactance is going to decrease. Therefore, a lot of the signal here at the output is going to go past this block, which is going to offer less resistance this time, and therefore gain is going to go down because this V naught is going to be smaller. Okay, so